let's do another example here of finding zeros using the fundamental theorem of algebra. Let's start with f of x equals x to the third minus x squared minus 9x plus 9. So I'm not given a zero, but I do know that I should have 3 zeros. At least one of the zeros will be real because this has to cross the x-axis someplace. The reason I know it has to cross someplace is because it starts down and goes up, so it's got to cross at least one place. So to find the zeros, I'm going to do the possible factors of 9, plus or minus 1, plus or minus 9, and plus or minus 3. The factors of the leading coefficient is 1, so I have plus or minus 1. So 1 divided by 1 would be 1 and negative 1. 3 divided by 1, I want to test 3 and negative 3. 9 divided by 1, I want to test 9 and negative 9. So at this point in time, I could do guess and check to see where I have zeros. I'm not going to use guess and check because I have a graphing calculator. But if I didn't, I could sure try 1 and then try negative 1 and look until I found one that gave me a 0 in this spot right here. What I'm going to do is use my resources and see if I can find one on the graphing calculator. So I'm going to go to y equals x and type in my function, x cubed minus x squared minus 9x plus 9. And then I'm going to hit graph and see if I can see some places where it crosses the x-axis. It looks like all of my zeros are going to be real zeros. I'm going to have one at negative 3, one at positive 1, and one at positive 3. I'm going to check that out by looking at the table. Yep. Find the place where I get 0 for y. Negative 3 was 1. And 1 was 1, and 3 was 1. So I'm looking for the places where I have a number for x and a 0 for y. So now I know which numbers I want to try. What I found from my graphing calculator is that negative 3 would be a 0. If I didn't have the graphing calculator, I would just start choosing from these numbers until I found one that gave me a 0. This gives me 0. Yay. That means this is a 0. Since I started with x cubed, I know my answer is x squared minus 4x plus 3, and I want to see where this equals 0. I'm going to check to see if it factors. If it doesn't factor, I would have to use a quadratic formula, but it looks like this one's going to factor to x minus 3 and x minus 1. So x equals 3, that would be a 0, and x equals 1 would be another 0. So my intercepts would be at negative 3, 0, 3, 0, and 1, 0. These would all be roots of that equation.